A single drone attack in the Red Sea can cost an enemy just $20,000, but forces the U.S. Navy to burn over $4 million per interceptor to stop it. Last winter, one American destroyer intercepted more than 50 threats in just 3 months, pushing its missile magazines toward empty while trade ground to a halt. What happens when the world's most powerful navy faces an enemy it cannot afford to fight? The answers and their consequences are just beginning. October 2023 brought a new kind of battle to the Red Sea. On the bridge of USS Carney, crew members tracked a fast-moving blur on radar, another inbound drone, one of dozens that day. The destroyer's alarm sounded as operators identified not just a single threat, but a coordinated salvo. Houthi forces had begun launching waves of suicide drones and anti-ship missiles, targeting commercial vessels moving through one of the world's busiest shipping lanes. The air was tense as watchstanders relayed coordinates and firing solutions. Each intercept meant lives and livelihoods on the line. Merchant ships carrying oil, grain, and electronics now found themselves rerouting or stranded, their captains calling for help over emergency channels. Insurance rates for these journeys spiked overnight, and some vessels began the long detour around Africa, adding weeks to delivery times. In just 3 months, the Carney alone intercepted more than 50 drones and missiles. The Red Sea had become a live fire zone, with the world's supply chains caught in the crossfire. A single Houthi suicide drone costs about $20,000 to build, some barely more than a family sedan. To stop it, the Navy relies on the SM-6 Interceptor, a missile with a price tag of $4.3 million. For every drone destroyed, the defender spends more than 200 times what the attacker does. Multiply that gap by the scale of a modern raid. A swarm of 20 drones launched in a single attack can force a ship to fire off more than $80 million in interceptors in just minutes. The math is relentless. One side spends pocket change, the other burns through the equivalent of a small town's annual budget every time it pulls the trigger. Naval analysts warned that this is not just an operational headache, it is a financial trap. No fleet, no matter how well funded, can afford to keep trading million-dollar missiles for cheap drones. The longer the exchange continues, the more the balance of power tilts toward the attacker. How long can this equation hold before defenders are forced to rethink the rules? An Arleigh Burke class destroyer carries exactly 96 vertical launch cells, each one holding a precious missile. These steel tubes are welded deep into the ship's deck. Once a missile is fired, that cell stays empty until the destroyer returns to port. There is no way to reload at sea. With every drone intercepted, the magazine shrinks. Commanding officers watch their inventory drop on digital displays, each launch bringing the ship closer to the dreaded word, Winchester. When the last missile leaves the rail, the destroyer becomes a billion-dollar target, with little left to defend itself. Reloading is not a quick fix. Sailing to a friendly port for new missiles can take days or even weeks, pulling the ship off station and leaving a gap in the defensive line. In a campaign of constant attacks, the decision to stay and fight or break away to reload is not just tactical. It is a gamble with the safety of the ship, its crew, and every vessel counting on its protection. Years before the first drone struck in the Red Sea, Navy strategists were already studying the economics of future conflict. In 2018, a series of classified assessments landed on the desks of senior planners. The reports warned that adversaries would soon use swarms of cheap drones not to sink ships, but to drain budgets and exhaust ammunition. Analysts ran the numbers. A single destroyer could be forced to spend tens of millions of dollars in minutes, all to stop a handful of low-cost threats. The threat was not just physical, it was financial. Planners pushed for urgent investment in technologies that could break this pattern. Budget requests began to shift, quietly channeling funds toward directed energy research and non-kinetic defenses. The goal was clear: move beyond the old playbook of missile versus missile and invent new ways to defend the fleet. By 2019, these warnings had become marching orders. The Navy would have to innovate or risk fighting a war it could not afford to win. In 2022, the Navy's logistics teams pulled off a maneuver that once seemed impossible. Two warships, each displacing over 9,000 tons, matched speed at 15 knots in open water. On the deck, sailors and crane operators worked in concert, guiding a 30,000-pound missile from a transfer barge into the destroyer's vertical launch system. The entire operation played out while both ships were underway, their hulls rolling and pitching with the sea. For decades, reloading missiles meant a forced retreat to port, sometimes halfway around the world, leaving gaps in coverage and breaking the rhythm of naval operations. Now, with the tested transportable rearming mechanism, a destroyer could replenish its magazine in hours, not weeks. Deck crews no longer face the old dilemma of choosing between staying in the fight or abandoning their post to reload. This breakthrough didn't just save time, it kept the fleet forward, closing a vulnerability that adversaries had counted on. The rules of persistence at sea had changed, one missile at a time. On board a modern destroyer, the hum of machinery is interrupted by a new kind of weapon, one that fights with light instead of explosives. The Helios laser, a 60-kilowatt directed energy system, draws its ammunition from the ship's own power grid. Each shot costs less than $100 in fuel, a fraction of what even the cheapest missile demands. Operators monitor screens as the laser locks onto an incoming drone, targeting vulnerable sensors and control surfaces. 10 seconds of concentrated energy is all it takes to blind, burn, or cripple the electronics, sending the threat tumbling harmlessly into the sea. The ship's power officer keeps a close eye on the load, knowing the only real limit is how much energy the generators can deliver. For the first time, the magazine is measured not in steel tubes, but in megawatts. Yet even as engineers celebrate these victories, a stubborn problem remains. Helios can engage only one target at a time. When a dozen drones approach in formation, the laser's beam must leap from one to the next, buying precious seconds but never outpacing a true swarm. The promise of unlimited shots comes with a catch. In the face of massed attacks, electricity alone is not enough. Engineers at the Naval Surface Warfare Center gather around a ruggedized console, monitoring the output of a new kind of weapon, one that does not rely on burning fuel or launching metal. Instead, high-power microwave generators pulse out bursts of radio energy, measured in megawatts, through a broad cone that sweeps the sky. When the system fires, the effect is invisible but devastating. Electronics inside dozens of incoming drones fry in an instant, their circuits overloaded by the electromagnetic surge. Unlike lasers, which must track and burn each target one by one, this technology covers entire swarms at once. The physics behind it is simple. Microwaves disrupt the delicate chips and wiring that keep drones aloft. In testing, a single 12-megawatt pulse disables every drone caught in its path, regardless of how many are packed into the airspace. For the first time, defenders have a tool that matches the scale and speed of the threat. A simulated exercise in 2026 brought every eye in the command center to the screens. 50 drones closed in, weaving through the sky in coordinated waves. Operators tracked each target, hands poised over familiar controls, yet no missile launches followed. Instead, a single command initiated the new defense. Less than a second later, the tactical display changed. Every drone, from the lead to the stragglers, dropped off radar at once. No explosions, no interceptors, no debris, just silence, broken only by the steady hum of electronics in the control room. The exercise commander paused, then let out a breath. For years, the Navy had chased a way to end the cost spiral. Now, with one pulse, the threat was gone and every magazine remained full. The realization swept the room. The rules of engagement had changed in an instant. Warfare's economics are shifting. Lasers and microwaves now promise to outpace the swarm's cost advantage. As adversaries adapt and technology accelerates, the real contest moves from firepower to innovation. In this new era, the side that breaks the cost curve first will redefine naval power. What do you think?